NASA labeled 3 Atlas a routine comet, locked it in as non-threatening, and the world moved on. Then, defense insiders started watching.
No raw data was stolen, no dramatic takeover, just a subtle alignment of narrative that suddenly shut down doubt. If the Pentagon did not need NASA data, what did they need to manage? The official story seems complete, but why did the truth need chaperoning? Pay attention to how fast routine becomes untouchable, because that is where the real power hides. A telescope in Chile, part of NASA's Atlas survey, picked up a new moving object in the pre-dawn sky on July 1, 2025. Within hours, the detection was logged, coordinates measured, and the data sent straight to the Minor Planet Center in Cambridge, Massachusetts. The Minor Planet Center is the global clearinghouse for new asteroids, comets, and anything else that strays across the solar system. Every night, observatories around the world feed it position data. The rules are simple. If you spot something new, you submit your measurements. If enough independent observatories confirm the track, the Minor Planet Center assigns a provisional designation. For 3I Atlas, the sequence went into overdrive. The first batch of observations landed in the Minor Planet Center database by sunrise in the Americas. By midday, a handful of other telescopes, Pan-STARRS in Hawaii, a network in Australia, and a few European stations had sent in matching reports. The Minor Planet Center software ran the numbers, flagged the orbit as hyperbolic, and triggered the next step, official designation. The object became C25NA1 Atlas. Then, after a quick cross-check with orbital models, it was labeled 3-2 Atlas, the third interstellar visitor ever recorded. The entire pipeline from first light to interstellar label moved at a pace that would make most bureaucracies blush. Hours, not days. There is a reason for that speed. The system is built for impact threats. Anything on a strange trajectory gets priority. The same process that handled 1I Oumuamua and 2I Boris now locked in a new label for 3 Atlas. NASA's Center for Near-Earth Object Studies processed the Minor Planet Center data, ran their own orbit solutions, and published confirmation: no threat to Earth, natural comet. Case closed. For the public, the story was already finished. The label interstellar, routine, harmless, was now baked into every official update, establishing the narrative. The raw mechanics of the pipeline leave little room for drama: telescope, submission, clearinghouse, designation. Yet, the speed itself does something else. It gives certainty a head start. By the time most people even hear the name 3I Atlas, the label is already locked and the narrative already stable. The machinery of small body discovery is designed to move fast and to be decisive. That decisiveness can look like clarity, or it can look like the end of the story before the real questions even begin. The first official statement from NASA's Planetary Defense Coordination Office arrived with the language already set. The announcement named the object as Interstellar Comet 3-2 Atlas. The Minor Planet Center circulars echoed the same label. The European Space Agency and other astronomy groups repeated it. Within a single day, the object's identity was everywhere. Not a threat, not a mystery, not worth a second guess. The wording was clean, almost antiseptic. The fact sheet described a hyperbolic orbit commentary activity and a projected path out of the solar system. Every detail pointed away from drama. NASA's web page reassured the public. No impact hazard, no need for alarm, just a rare visitor from beyond. The press language steered clear of uncertainty. There was no mention of alternative possibilities, no reference to ongoing investigation. The public line was settled before most people even knew there was a question. No dissent appeared in the official channels. No major astronomer challenged the label in peer-reviewed venues. The first batch of news articles quoting NASA and the Minor Planet Center used the same words: routine, interstellar, harmless. The press kit left little room for speculation. The pipeline had done its job, delivering a story that was easy to repeat, easy to defend, and hard to question. But the speed and finality of the language did something else. It locked the public conversation into a single frame. By the time amateur astronomers or curious members of Congress started asking for more detail, the label had already hardened. The power of first messaging shaped what questions could even be asked. If the official line says natural comet, then every challenge sounds fringe by default. This is how narrative control works when it is woven into the machinery of public affairs. Not through censorship, but through timing and tone. The first words out of the gate become the anchor for everything that follows. The fact sheet becomes the filter. The story is routine. The label is locked and the conversation is already over, at least on the surface. International coordination and rehearsal. European officials described 3I Atlas as a rare opportunity for coordination. In public statements, the language leaned toward procedure, not drama. The object was logged, tracked, and labeled with the same crisp efficiency seen in previous cases. But beneath the surface, another motive flickered. These agencies treat every outlier as a live exercise, a chance to prove the machinery works. No one called it a drill. Still, the mechanics reveal a familiar pattern. Treat the event as a rehearsal for something worse. If a real threat ever appears, the expectation is that every pipeline from first detection to final press release will perform without hesitation. ESA highlighted the value of cross-checking ground-based observations with spacecraft data, noting the alignment of international teams and the technical process. The words test case never appeared in formal releases, but the actions matched the playbook. Every telescope, every analyst, every coordination call doubled as practice. The public explanation stayed simple. Confirm the object, update the records, reassure the world. But in the background, the system flexed its readiness muscles. The process was measured in hours, not days. Each agency from ESA to NASA followed the script. No ambiguity, no delay, no speculation. This is what preparedness culture looks like. Treat the routine as rehearsal. Treat the rare as a systems check. The object itself is less important than the response it triggers. If the language feels antiseptic, it is by design calm, controlled, and quietly intense. The point is not just to inform but to demonstrate control. When the next anomaly comes, the expectation is clear. The system will respond even faster with even less uncertainty. Every routine event is a test even if no one says so out loud. The Mars observation. Mars was never part of the original plan. But when 3 Atlas swept past, mission teams saw a rare opening. The Mars Reconnaissance Orbiter, deep in its own routine, was tasked for a distant shot. On October 3, 2025, its high-rise camera caught a faint blurry glow 30 million kilometers out. Barely a smudge, jitter stretching the light. The image lacked drama. No detail, no structure, just a fuzzy ball against the noise. But even a vague dot can matter. Spacecraft astrometry, even at this range, adds a new angle, a fixed point from a different orbit, a check against the swarm of Earth-based numbers. The Mars data joined the global pile, Atlas in Chile, Panars in Hawaii, telescopes across Europe and Australia, all feeding the minor planet center. Every new position, even a rough one, tugs at the orbit solution, tightening the fit. The real gain here was not a headline-grabbing breakthrough. It was about redundancy. A spacecraft in Mars orbit confirming the same track as Earth means less room for error. It means the machinery can cross-check itself under pressure. That's the practical benefit of rehearsal. Not precision miracles but system confidence. No one claimed a tenfold tightening of the orbit. No sudden jump in certainty. Just another data point logged and verified. Proof that when a rare object flies by, the network can reach beyond one planet. For the mission teams, it's a quiet win. The process held, the orbit held. The label Interstellar Harmless stood up to scrutiny even from a second world. That is how readiness is measured. Not in the drama of the images, but in the discipline of the response. The role of ARO in national security. ARO, the Pentagon's all-domain anomaly resolution office, sits at the intersection of national security and unexplained phenomena. Its charter is precise. Investigate anything airborne, transmedium, or submerged that cannot be positively identified and that might pose a risk to United States interests. But the fine print matters. It does not run its own telescopes. It does not command a fleet of satellites. It does not have the authority to red-ask missile warning radars or point a classified sensor at a comet just because it is in the news. Instead, AO acts as an analytic hub. It receives reports, reviews data from other agencies, and can request information through established channels. But every request must pass through a chain of command. The actual sensors and the raw feeds belong to other offices, Space Force, Missile Defense Agency, and the intelligence community. If ARO wants a closer look, it can ask. It cannot order. That distinction sets the boundaries. When 3 Atlas was discovered and quickly labeled a natural interstellar comet, the official verdict landed outside the core mission of AR. A Pentagon spokesperson told Defense Scoop that AR was following 3 Atlas closely but not assisting NASA. The reason the object was assessed as a comet, not a UAP, no unknown maneuvers, no unexplained propulsion, no threat indicators. Once the planetary defense pipeline locked in the natural label, ARO's role became passive. No special tasking, no classified collection order, just internal monitoring of NASA updates, public releases, and perhaps a few interagency briefings for situational awareness. On paper, ARO authority is limited. It cannot seize data or block a civilian release. Its power is analytic, not operational. The office compiles reports, coordinates with other agencies and prepares talking points for leadership, but it does not control the flow of raw astronomical data. No organic sensors, no direct access. Its influence comes from the ability to interpret, to frame, and to ask questions that might shape how information is routed up the chain or how it is presented to the public. That is a gap most people never see. The machinery of national security runs parallel to public science, but with its own rules and its own boundaries. The question is not whether AA took over the 3 Atlas story. The real question is how the limits of its charter shape what the public is allowed to know and what remains just out of reach. Following closely, the ambiguity of defense language. A Pentagon spokesperson told Defense Scoop that AARO was following 3 Atlas closely, but also that it was not assisting NASA because the object was classified as a comet, not a UAP. 2 phrases appeared side by side. One signaled attention, the other draws a line. Put together, they create a zone of ambiguity. Watching but not acting. Monitoring but not intervening. The official verdict was natural comet, no threat. That meant AARO's role stayed passive. No classified tasking, no joint sensor orders, just updates, briefings, and internal awareness. But the language leaves space for interpretation. Following closely invites the idea that someone somewhere is paying more attention than the public feed admits. Not our mission closes the door on questions about deeper involvement. Both phrases have become standard in the national security playbook. They keep the story open without promising anything concrete. The effect is subtle. The public hears assurance and distance at the same time. The story is locked, but the possibility of a second channel lingers. Some suggest this is by design. The wording avoids commitment, sidesteps speculation, and shields the machinery from scrutiny. Others see it as simple compartmentalization. One office tracks, another decides, and the public gets only the surface. There is no proof of hidden data or secret tasking for 3I Atlas. Still, the phrasing itself becomes a kind of signal. It tells you where the boundaries are and where the questions begin. When language is this careful, the gap between what is said and what is done becomes part of the story. What does following closely actually mean? And who decides when it is time to move from watching to acting? In the world of interstellar visitors, sometimes the most important evidence is not what is in the data, but how the story is told. The 2 skies, public versus classified data. Every position measurement for 3I Atlas landed in the Minor Planet Sense Open Catalog, circulars, telescope logs, and ground-based images. Anyone with a computer and enough patience could reconstruct the comet's path. This is the public sky. Transparent, collaborative, and designed for open debate. But that's only one half of the story. Parallel to the public feed, a second sky exists, one that is invisible to most astronomers. This is the world of classified surveillance. U.S. Space Command, Space Force, and legacy networks like the Space Surveillance Network and Space Fence maintain their own catalogs. Their sensors track everything from defunct satellites to unexpected visitors. The raw feeds from missile warning radars, deep space telescopes, and high-powered infrared satellites never appear in the Minor Planet Sense logs. These systems are built for warning, not discovery. Their data is filtered, sanitized, and routed through secure channels. Sometimes fragments of these observations reach the public, stripped of detail, cleansed of anything that might reveal capabilities. Sometimes they never leave the classified archive at all. For 3I Atlas, there is no public record of a classified data set. No memo, no leak, no whistleblower. But the structure is there. U.S. government documents acknowledge that defense sensors contribute to near-Earth object detection with data sometimes delayed or redacted before release. Official agreements between NASA's Planetary Defense Coordination Office and U.S. Space Command outline data sharing protocols. Portions of these agreements are public. The details what gets shared, when and how much are not. In the case of 3-2 Atlas, every official statement points to the public pipeline, but the existence of a parallel track is not in question. It is standard practice. Any object with a strange trajectory is likely to be flagged by both civilian and military systems. The difference is what happens next. In the public sky, debate is encouraged. In the private sky, information is managed. This separation is not accidental. National security sensors are calibrated for threat detection. Their catalogs are built for situational awareness, not scientific curiosity. When a new object appears, the question is simple. Is it dangerous? If not, the data may trickle out eventually. If there is any uncertainty, review gates snap shut. Approval chains kick in. The public never sees the full feed. Sometimes the only signal is the absence of information, a gap in the record, a delay that cannot be explained by weather or bureaucracy alone. The result is two versions of the sky, one for public consumption, one for internal review. The 3 Atlas episode fits this pattern. The official story is clean, quick, and decisive, but the machinery behind it is layered. Open catalogs and classified logs run side by side, each with its own priorities. The public narrative is stable. The private narrative, if it exists, is silent. For most people, the distinction is invisible. For those who look closer, the question lingers. How much of the sky do we actually see? And how much is curated before it ever reaches the public eye? The government shutdown and data silence. On October 1, 2025, the U.S. government shut down. NASA mailboxes bounced back with auto replies. No funding, no monitoring, no new releases. For anyone watching 3 Atlas, the public feed went quiet. Days passed. Amateur astronomers refreshed minor planet center logs, waiting for images or orbital updates. Nothing came. The usual data trickle, ground-based snapshots, trajectory refinements, even the expected press briefings froze in place. NASA officials, when reached by reporters, pointed to the shutdown. They said new findings would be shared once the government reopened. But silence does strange things to a story. Pressure started to build outside official channels. Harvard astronomer Avi Loeb called out the gap, demanding public access to the latest data. On October 31st, Representative Anna Paulina Luna sent a formal letter to NASA acting administrator asking for immediate release of all 3 ILS records, images, and technical data. She was not alone. Congressional aides fielded calls from space enthusiasts and skeptical constituents, all asking the same question. Why had the feed gone quiet? Behind the scenes, NASA arranged a direct call with Representative Luna and her staff. The meeting was not classified and it was not public. Defense Scoop reported that NASA officials explained the delay, cited shutdown constraints, and promised to release findings after funding was restored. There is no public record of what, if anything, was shown to lawmakers before the shutdown lifted. The raw chain of custody for every image and every data file remains out of reach, buried in internal systems and shielded by routine bureaucracy. For the Mars mission teams, the timing was a headache. The Mars Reconnaissance Orbiter had captured a faint image of 3 Atlas weeks earlier, just a blurred glow 30 million kilometers out. But even a low-resolution shot from another planet could have added confidence to the orbit solution, or at least reassured skeptics that nothing was being hidden. Instead, the image sat in limbo. No public release, no technical breakdown, only the promise that once the shutdown ended, new material would appear. When the government finally reopened in mid-November, NASA moved quickly. On November 20th, the agency released a batch of high-resolution images and held a public event to address the backlog. The official line blamed the delay on the funding lapse, but the silence had already done its work. Online, theories multiplied. Was the delay just bureaucracy, or had someone used the gap to filter the story? No one outside NASA and Congress could say for certain. The shutdown created a vacuum. In that space, speculation flourished. The lesson was simple. When the feed goes quiet, trust Eridus and the story takes on a life of its own. Historical precedent. Vela and 2008 TC3. In the 1970s, a set of satellites called VA orbited Earth with one job: detect nuclear detonations. Instead, they found something no one expected. Brief, powerful flashes of gamma-ray radiation coming from deep space. The data sat classified for years. Only after internal review and declassification did the scientific community learn that VA had opened a new chapter in astrophysics: gamma-ray bursts. The discovery changed astronomy. But the path from detection to public knowledge ran through a military filter. Raw readings were reviewed, sanitized, and only then released. The mechanism was simple. Protect national security, then share what is safe. The pattern did not end there. In October 2008, a small asteroid named 2008 TC3 was spotted hurtling toward Earth. The Catalina Sky Survey flagged it, and astronomers tracked its path as it closed in. When it struck the atmosphere over Sudan, classified U.S. government sensors built for missile warning recorded the explosion. The official confirmation of the impact came not from civilian telescopes, but from defense data. NASA acknowledged the help, but only the basics were shared. Details about the sensors, their precision, and the raw measurements stayed behind closed doors. Over time, a filtered version of the data entered the scientific literature. But the full record never did. These are not isolated cases. Defense satellites and radars routinely collect information on space events that later become public if and when review gates open. The process is not a conspiracy. It is a system. Threat first, science later. Every bit of data passes through approval chains designed to protect capabilities and priorities. Sometimes, as with Vela and gamma-ray bursts, the delay is years. Other times, as with 2008 TC3, the gap is just days or weeks. But the pattern holds. Military sensors catch something. Internal review decides what can be shared, and only then does the wider world get a look. The mechanism is proven. The gates exist. There is no need for anyone to take over a civilian survey when the system already routes sensitive data through layers of review. The public pipeline, astronomy circulars, press releases, outreach pages, runs in parallel with a private channel that answers to different rules. When a new object appears in the sky, the question is not just what it is, but who gets to decide when and how the story is told. 6 theories in the contest for the sky. Explanations circle the aftermath of 3I Atlas. Each one drawing its own boundary between what is shown and what is withheld. Each theory leaves a gap, an invitation for the next question. First, narrative control. The official story was an interstellar comet and no threat. That label landed before most people even knew there was a question. The label was everywhere, unchallenged, immediate. Some say this is not about hiding facts but about setting the frame. The first words shaped the whole conversation. There is no public evidence of a hidden debate, but the speed and uniformity of the message prompts a question. Who decides what gets said and what is left out before the public ever sees it? Second, dual channels, defense sensors, and classified telescopes sweep the sky every night, collecting data that rarely surfaces in public science. The Pentagon does not rely on NASA alone. It runs its own surveillance and its own files. NASA becomes the public face, the last stop in a chain that starts much deeper. The public sees what is cleared for release. There is no proof of a secret 3 Atlas file, but the system is built for 2 skies, 2 stories running in parallel. Third, social management. The object itself may be ordinary, but uncertainty spreads fast online. Delays, gaps, and flat language create a vacuum. Into that space, speculation rushes, aliens, cover-ups, institutional distrust. The real challenge can become managing the story, not the comet. The aim is calm, lock the narrative, prevent chaos. No memo says contain the internet. But the pattern is familiar. Fourth, verdict too soon. The official answer arrived before the question had settled. The tone felt final, the language absolute. Was that certainty earned by the data? Or did the need for a stable message outpace what was actually known? No internal draft has surfaced. No document shows what else was weighed? The question lingers. Did the machinery move too fast? Fifth, mundane confusion. Bureaucracy is slow, sometimes grinding to a halt. Shutdowns, approval chains, missed emails, ordinary delays can look suspicious from the outside. A gap in communication, a funding hiccup, a closed office, the shape of secrecy, even when nothing is hidden. From outside, a delay is just a delay. The public cannot tell which gaps are innocent and which are engineered. Sixth, rehearsal. Rare events become drills for the system. Agencies treat anomalies as tests, flexing their pipelines, checking readiness, rehearsing for the real threat. Officially, nobody calls it practice, but the mechanics are the same. Cross-checks, coordination, locked messaging. The object moves through the sky. The institutions move through their playbooks. The public version is clean. The system sharpens itself in the shadows. No verdict, only a set of interpretations, each tied to a different motive and a different silence. The evidence fits more than one reading. The tension lives in what is missing. The drafts unseen. The data unreleased. The conversations that never left closed rooms. 3 Atlas is not just a comet. It is a contest over who gets to write the sky. Today the official story sits unchallenged. The mechanisms that shape it remain invisible by design. When defense attention shadows a public science event, the line between information and narrative blurs. The real question is not what is hidden, but who decides what is revealed. Until transparency is more than a label, trust in the sky above us is managed, not earned. What do you see? The whole sky or just the window they picked?